This is Bob Capetta, and this lesson is on derivatives of inverse trigonometric functions. So we're going to start with the inverse sine function. So I have y is the inverse sine of x. My goal is to find the derivative, and I'm going to do that by appealing to implicit derivatives. So if y is the inverse sine of x, that means that the sine of y equals x. Next, I'm going to take the derivative with respect to x at both sides. The derivative with respect to x of sine y and the derivative with respect to x of x. The derivative of sine y with respect to x is cos y dy dx. The derivative of sine of something, cos of something times the derivative of something. So cos y dy dx. d dx of x, of course, is just 1. So if I want to solve for dy dx, I divide both sides by cos y, and I get dy dx is 1 over cos y. But that's not my final answer. I want my final answer to be a function of x. So I've got to do some geometry to get there. Well, this is what I know. I know sine of y is x, or sine of y is x over 1. I want to create a triangle where the sine of y is x. Opposite is x, hypotenuse is 1. Sine, of course, is opposite over hypotenuse. So notice, sine of y, opposite is x, hypotenuse is 1. Sine of y is x over 1. What is this third side of the triangle? I will get that using Pythagoras. So I'm calling that third side b for base. Base squared plus x squared is 1 squared, or 1. Solving for the base squared, of course. Base squared is 1 minus x squared, so the base is the square root of 1 minus x squared. So that's the third side of the triangle. And then knowing that, let's go back to look at what I needed. The derivative of the inverse sine function, that's dy dx, is what is 1 over cosine y. Now looking at this triangle, what is cosine y? Well, cosine is adjacent over hypotenuse. Adjacent, root 1 minus x squared over hypotenuse over 1. So that's my cosine of y. Cosine of y is root 1 minus x squared. So to finish my problem here, dy dx is 1 over cosine y. dy dx would be 1 over the square root of 1 minus x squared. So that is my derivative of the inverse sine function. Remember, I started with y is inverse sine of x. And now I have dy dx is 1 over root 1 minus x squared. I've successfully determined the derivative of the inverse sine. Let me summarize that here. Derivative of the inverse sine of x is 1 over the square root of 1 minus x squared. Now let's go ahead and use that with the problem. Let's take a look at the derivative with respect to x of the inverse sine of 3x plus 1. So where I have an x here, I'll replace that with 3x plus 1. Where I have an x here, I'll replace that with 3x plus 1. But don't forget the chain rule. The derivative of the inverse sine of something is 1 over the square root of 1 minus something squared times the derivative of the something. So notice what I've done. I replaced x with 3x plus 1 here. 1 over square root 1 minus 3x plus 1 squared times the derivative with respect to x of the something times the derivative with respect to x of 3x plus 1. Well, 3x plus 1 squared, 9x squared plus 6x plus 1. Derivative of 3x plus 1 is just 3. So, simplifying this fraction, the 3 is upstairs. 1 minus 9x squared will leave me negative 9x squared minus 6x will leave me negative 6x. 1 minus 1, that goes away. So what's my final answer? Simplified going to be 3 divided by the square root of negative 9x squared plus 6x. So again, I want you to look at this. The derivative of the inverse sine of x is 1 over the square root of 1 minus x squared. Keep that in mind because we're going to go ahead and do inverse cosine next. So this time I want y to be the inverse cosine of x, and I want to find dy dx. That would be the derivative of the inverse cosine of x. Again, I'm going to appeal to implicit derivatives. So if y is the inverse cosine of x, that means cos of y is x. Let's take the derivative with respect to x of both sides. The derivative with respect to x of cos y is the derivative with respect to x of x. Derivative with respect to x of cos y, negative sine y, dy dx, using the chain rule. The derivative with respect to x, of course, is just 1. So now what I have is I have dy dx will be 1 over negative sine y, or negative 1 over sine y. And similar to the last example, we're going to need to go ahead and use geometry to figure out what sine y is as a function of x. Right now, what do I know? I know cosine of y is x. Cosine is adjacent over hypotenuse. So x is x over 1. So the adjacent could be x, the hypotenuse could be 1. Notice cosine y adjacent over hypotenuse. But I have the altitude of this function that I don't know. I'll call that a. So what am I going to say? X squared plus altitude squared is 1 squared, or 1. So solving for a squared is 1 minus x squared. A is the square root of 1 minus x squared. So that's the third side of the triangle. Now, what do I need from that? Look at what we have over here. dy dx is negative 1 over sine y. I need sine y. What is sine? Opposite over hypotenuse. Opposite root 1 minus x squared. Hypotenuse is 1. So sine y root 1 minus x squared over 1, or root 1 minus x squared. Now where does that get substituted? Over here for my dy dx. So dy dx will be negative 1 over square root of 1 minus x squared. Which looks an awful lot like what we had for inverse sine. Remember, the derivative of inverse sine of x was positive 1 over the square root of 1 minus x squared. But let's go ahead and do a problem that uses the chain rule with this. So here is our rule. The derivative with respect to x of inverse cosine x is negative 1 over root 1 minus x squared. And what do I want us to examine here? The derivative with respect to x of the inverse cosine of the square root of x. So notice what we're going to do. The derivative of inverse cosine of something, negative 1 over root 1 minus the something squared. The something is root x. Root x squared will just be x. Times the derivative of the something, to use the chain rule. We must remember the chain rule. So notice root x squared times the derivative of root x. Root x squared is just x. The derivative of root x, that's the derivative of x to the 1/2 power. We can pull that 1/2 down front, 1/2 x to the negative 1/2. But what is x to the negative 1/2? That's 1 over x to the 1/2, or 1 over the square root of x. So upstairs I have 1 times 1 times 1. Upstairs I just have 1. Downstairs 2. Square root of x times square root of 1 minus x. That would be square root of x minus x squared multiplying into root x. And that's what I get. Except I think I lost a negative sign. So let's go ahead and fix that. And so I've corrected the typo. Derivative of inverse cosine, negative 1 over root 1 minus x squared. So it's negative 1 over 1 minus something squared times the derivative of the something. Root x squared, of course, is x. The derivative of x to the 1/2 would be 1/2 x to the negative 1/2. So now I have negative 1 over 2, again, root x times root 1 minus x, root x minus x squared. So that typo is fixed. Okay, we continue. Next question I have, y is the inverse tangent of x. We're going to find its derivative using implicit differentiation. So therefore, tangent of y is x. Take the derivative with respect to x of each side. Derivative with respect to x of tangent y is derivative with respect to x of x. So derivative of tangent y is secant squared y, dy dx is 1. Divide both sides by secant squared y. I get dy dx is 1 over secant squared y. So I need to create a triangle to determine what secant squared y is. What I have here is tangent of y is x. Now tangent is opposite over adjacent. Opposite is x, adjacent is 1. Tangent of y opposite over adjacent, x over 1. I've got to find the third side, called the third side c. Base squared plus altitude squared, 1 squared plus x squared is c squared. So x squared plus 1 is c squared. C, of course, is the square root of x squared plus 1. That gives me the hypotenuse for this triangle. We have that. Now, again, I want to get secant squared y, so I need secant y, but let's first start with cosine, because secant is reciprocal of cosine. So cosine is adjacent over hypotenuse. Cosine is 1 over the square root of x squared plus 1. Secant is the reciprocal, so secant of y would be root x squared plus 1. And then square both sides to give me secant squared y is x squared plus 1. Knowing that, I can make my substitution and say dy dx is 1 over x squared plus 1. So that is our derivative of inverse tangent of x. So the derivative of inverse tangent of x is 1 over x squared plus 1. Let me look at an example using the chain rule. So the derivative of inverse tangent of 2x. So we would replace the x with 2x. The derivative of inverse tangent of something, 1 over something squared plus 1 times the derivative of the something using the chain rule. So 1 over 2x quantity squared plus 1 times the derivative of 2x, which you can see. 2x quantity squared, 2x times 2x is 4x squared. The derivative of 2x is 2. So my final answer here is going to be 2 over 4x squared plus 1 for the derivative of inverse tangent of 2x. Okay, next I want to look at inverse secant. So y is inverse secant x. You'll see the strategy. We're going to use an implicit derivative. That means secant y equals x. Taking the derivative with respect to x at both sides, d dx of sec y equals d dx of x. The derivative of secant y, sec y tan y, dy dx equals d dx of x, which is just 1. So solving for dy dx, which of course is the derivative of inverse secant of x, dy dx would be 1 over sec y tan y. Now, what are sec y and tangent y? To find that, I'm going to draw a triangle. But what do I know? Sec y is x, but I'd rather work with the reciprocal. So if sec y is x, that means 1 over cos y is x. We'll take the reciprocal of both sides. That means cosine of y then would be 1 over x. Cosine is adjacent over hypotenuse, so the adjacent is 1 and the hypotenuse is x. So I've got to find the altitude of this triangle, so I need to use the Pythagorean Theorem again. So 1 squared base squared plus altitude squared is x squared. So a squared is x squared minus 1, so a is the square root of x squared minus 1. So that's the altitude of this triangle. So now I have this. Now I know what sec y is. Fine, sec y is x. Do I know what tangent y is? Well, let's take a look. Tangent y is opposite over adjacent. Tangent y is root x squared minus 1 over 1. So tangent y is root x squared minus 1. Now I told you sec y was x, but you can also get it from the triangle, right? Cosine y is adjacent over hypotenuse. Cosine y is 1 over x. Taking the reciprocal, secant of y is x. So sec y is x. Tangent y is root x squared minus 1. Making the substitutions over here, I get dy dx is 1 over x times the square root of x squared minus 1. I just want to make a note, though. Notice in our triangle, x is the hypotenuse. Pardon my dog bark, she wanted some attention. X is the hypotenuse. The hypotenuse has to be positive for this to make sense. So this really is only true when x is a positive number. It's not going to become a big issue in this course, but it's something I think I should say. All right, so let's take a look at an example that uses the chain rule with inverse secant. So here's our rule. The derivative of inverse secant of x is 1 over x times the square root of x squared minus 1. So what's the derivative of inverse sec of 5x? We're going to replace the x with 5x, replace the x with 5x, but don't forget times the derivative of the 5x. Derivative of inverse sec something, 1 over something, square root something squared minus 1 times derivative of something. So 5x quantity squared is 25x squared. This is just 5x. The derivative of 5x, of course, is 5. And notice how this 5 and this 5 would divide out. So we get our final answer of 1 over x times the square root of 25x squared minus 1 to be the derivative of the inverse secant of 5x. So let's review. We have basically 6 rules for derivatives of inverse trig functions. What are they? The first one we did, the derivative of inverse sine of x is 1 over the square root of 1 minus x squared. And despite my typo we eventually fixed, the derivative of inverse cosine x is exactly the same except there's a minus sign on top. Derivative of inverse cosine is negative 1 over square root of 1 minus x squared. Next up was derivative of inverse tangent. That was 1 over x squared plus 1. I did not do this in the video, but I encourage you to take a look at it. if you go through and do the geometry, you will find the derivative of inverse cotangent is -1 over x squared plus 1. So same pattern holds. The derivative of inverse tangent and the derivative of inverse cotangent are the same, except one is a multiplier of -1. And for x bigger than 0, the derivative of inverse secant is 1 over x times the square root of x squared minus 1. And thankfully, the pattern also holds for the derivative of inverse cosecant, which is -1 over x times the square root of x squared minus 1. And that will conclude this lesson.